Now we will do the series of videos to do hypothesis testing for sample means and population means when we have quantitative variables or we have numbers that we're dealing with. So a fitness tracker company claims users average more than 7,000 steps a day. A sample of 45 users has a mean of 7,410 steps with a standard deviation of 1,250 steps. We're going to test the claim at an alpha of 0.05. So before we do any testing, we need to go get what is our null and alternate hypothesis and what type of tail is this test, and then we can go grab all of our numbers. So a fitness tracker company claims that users actually average more than 7,000. So what we believe right now is that the average is 7,000, and they are testing if the actual average of people is larger, is more than 7,000. So we're going to use that the mean is greater than 7,000. Whenever our alternate hypothesis is a more than, that we're using the greater than symbol, this is going to be a right tail test. So now once I go find my test statistic, I will turn that into the right tail and I'll automatically have the p-value we need in order to evaluate the conclusion. Now, as I sort of mentioned today, we are going to be using a t statistic. Our test statistic will be t. We will be using a t-score when we do all of our hypothesis testing for sample means and population means for the purpose of this Introduction to Statistics class. There are situations where we have other tests available, but for this class, when we ask for a test statistic, we will be doing a t-test. So we need to get a t-score or a t-statistic. We get the statistic just like we've been doing with z-scores. We're going to take the sample mean minus what we think is true from the population over the sample standard deviation over the square root of the sample. So for this problem, the sample, it said, so when I go to the sample has this as the mean, so that automatically is x bar. X bar is your sample mean. So we have 7,410 minus what we think is true, which we stated in the null hypothesis, 7,000, divided by the sample standard deviation over the square root of the sample, which had 45 people in it. So 7,410 minus 7,000 divided by the sample standard deviation over the square root of the sample. So our test statistic, our t-score, came out to 2.2002. Okay. What we just calculated is our test statistic, which I've also been calling a t-score or z-score, but that's the same thing. A test statistic is the same as like a t-score. So I'm going to take that test statistic, that t-score, and I need to go grab the right tail because we already identified that this is a right tail test. Since it's a right tail test, once I get the right tail, that automatically is the p-value that we will use for our conclusion. But when we do a t-test, we are going to be using a different type of formula in Excel. So let me get my t-statistic, 2.2002, lots of twos. So let me type in my t-score here, 2.2002. To get the left score when we're doing t-statistics and t-scores will be equal t.dist. And now I'm going to type in the t-statistic we just got, comma, we need the degrees of freedom. To get our degrees of freedom, we take how big was the sample of 45 minus 1. So I'm going to type in, let me re-edit this. Okay, good. No, let me edit. Okay, thank you for your patience, y'all. All right, so I typed in my t-statistic, comma, I needed 44 because my sample was 45, so 45 minus 1 is 44, comma, true. And now it should like my revisions. There we go. But we already said this is a right tail test. If you have a left tail, we get the right tail equals 1 minus the left tail. 0.017. So my right tail came out to 0.017. And since this is a right tail test, that is also my p-value. So now we can use that to determine our conclusion. In this case, my p-value is less than the alpha that we want to use for the problem. When your p-value is less than the alpha, we have statistically significant enough evidence to reject the null hypothesis in favor of the alternate hypothesis. So we would reject that the average number of steps is 7,000 in favor that the actual average is more than 7,000.